Back. Today is Wednesday, April 22nd, 2020. We're going to wrap up the benchmark, LS 1-6, 1-7, photosynthesis, cellular respiration, and we're going to talk about the carbon cycle. No, I'm not talking about the water cycle.
The water cycle.
Haha. All right. Well, actually, it is kind of related to the water cycle. So, the water cycle is where the water molecules get recycled throughout the atmosphere through evaporation, condensation, precipitation. So the water molecules never disappear. It's the same thing with the carbon cycle. The carbon atoms never disappear. They just get reused again and again. We talked about how in photosynthesis, the carbon dioxide goes into the leaves, and the leaves break down that carbon dioxide and they create glucose. That glucose is eaten by other organisms, it can decay, and then when the organisms eat it, then cellular respiration breaks down the glucose and makes the carbon dioxide again. So today's benchmark is a wrap up. So LS 1-6, 1-7, carbon cycle. And then for extra credit, you can do the balancing equations activity online. And make sure to study for your quiz and finish it by this week. The benchmark is to explain how carbon molecules are reused again and again in the carbon cycle. So what is the carbon cycle? On page 63, if you can take notes, you should notice that the carbon is cycled again and again. It's never created, it's never destroyed, it's just reused again and again. In photosynthesis, right here, the carbon dioxide goes into the chloroplast, so carbon goes in. So we're just going to follow the carbon. Carbon goes in. So remember, there's actually 6 carbons that are going to go in, and those 6 carbons are going to combine to become glucose, C6H12O6. Once the glucose is made, the glucose gets used up by cellular respiration. So C6H12O6 go into the mitochondria. So maybe the frog eats a fly or something like that. And inside the mitochondria, that C6H12O6 gets broken down into carbon dioxide, 6 carbon dioxides. So 6 of them come out, and those 6 go back into another plant. So photosynthesis takes the carbon dioxide, creates the carbohydrates, the glucose, C6H12O6, and the cellular respiration takes the carbohydrates, the glucose, the C6H12O6, and breaks it back into carbon dioxide. So this carbon is used again and again and again, and has been used for millions of years. In fact, the same carbon molecules that the dinosaurs used are the same carbon atoms that we are using. So if you're breathing in, if you're eating glucose, that glucose might have come from an ancient dinosaur somewhere, right? Maybe we can think of something more recent. Maybe Justin Bieber breathed out some carbon dioxide, and then a plant nearby took that carbon dioxide and created an apple, and then someone ate that apple. You ate that apple, so you are in essence eating a part of Justin Bieber. How amazing is that? All right, so that's carbon cycle, page 63. For extra credit, please do the balancing equations website. So if you go to Google Classroom in week 4, there is a link here for the balancing equations website. You should remember this from first quarter. What you're going to do is you're going to, if you need to repractice again, you can repractice again. You can go to the game, and the challenge is to do all 3 levels. Level 1, I would always start with 1 molecule of each. And what you're going to do is you're going to count how many carbons. So you have 1 carbon here and 1 carbon here. So far, so good. You can count how many oxygens. Where you have 2 oxygens here, but 3 oxygens here. That's no good. We need more oxygens. So let's add another carbon dioxide. Now we have 4 oxygens. That's still no good. And we have 2 carbons, but we only have 1 carbon. So let's balance the carbon here. Hey, look at that. We have 2 carbons, and then 4 oxygens, and 4 oxygens, and we can check, and voila, 2 points there. All right, so show me a selfie of your final screen when you've finished all 3 levels, and I'll give you an extra credit point. Good luck. See you tomorrow.
I got a balanced chemical equation to differential equation. Just start from the beginning and look at the coefficient, and that